Hello again. We are continuing our discussion on solving quadratic equations, and we're going to talk about another strategy today, and that is solving those quadratic equations by factoring. All right, so let's get started. I'm going to remind you quickly what we mean by factoring. That's where we have something like x squared plus 11x plus 24, and what we do is we look for two numbers that multiply to give 24 and add to give the middle number, which is 11. All right. So those two numbers would be 8 and 3. So in this case, x squared plus 11x plus 24 would factor to be x plus 8 times x plus 3. And if you were to use distributive property on the red parentheses, you would get back to the original expression. All right, so now let's use equations to use this factoring skill to solve an equation instead. So if I have the same expression equal to 0, x squared plus 11x plus 24 equal to 0, then I can rewrite that expression as the factored form of that expression, which is x plus 8 times x plus 3 equals 0. This becomes very helpful because now I've got two quantities being multiplied together to give 0. Well, if two things multiply to give 0, then either the first thing is equal to 0 or the second thing is equal to 0. All right, so I just look at those two things separately. So either x plus 8 is going to equal 0 or x plus 3 is going to equal 0. So I solve each of those linear equations now separately, and I get my two solutions. So for the first linear equation, x would have to equal -8. And for the second linear equation, x would have to equal -3. So those are my two solutions to the equation x squared plus 11x plus 24 equals 0. And I could check those if I wasn't certain, and you're more than welcome to try that. Here's another example. If I have x squared minus 16x plus 64, if I were to factor that, then I would need two numbers that multiply to give 64 and add to give -16. And those two numbers would be -8 and -8. So in order to factor that, I would end up with x minus 8 times x minus 8. Now those two factors are exactly the same, so really it's not like I have two different solutions, I just have one, and we'll see that as we solve the equation. So if I wanted x squared minus 16x plus 64 to equal 0, then I could rewrite the left-hand side as x minus 8 times x minus 8 and set that equal to 0. So obviously, since those factors are the same, I really only need to solve the linear expression x minus 8 equaling 0. I only need to do that once. So set x minus 8 equal to 0. I solve that and I get that x equals 8. And that is the only solution to this quadratic equation, x squared minus 16x plus 64 equals 0. That's the only x that will work. All right. Now, if there is a number in front of the x squared, we've talked about how to factor that. For example, 3x squared plus 8x plus 4 equals 0. Now, this time I need two numbers that multiply to give the first number times the last number, which is 12. But they still have to add to give the middle number, which is 8. So if I factor that, I'm looking for two numbers that multiply to give 12, which is what 3 times 4 is, and they have to add to give 8, which is the middle number. Those two numbers are 6 and 2. So here's how I factor. It's a little bit more of a detailed process to do this. So we will split the middle term. That's one way that we've talked about factoring once we find our two numbers. So if I split the middle term, 8x becomes 6x plus 2x. And those are my four terms there. And then I will factor each pair separately. So the first pair becomes 3x times x plus 2, and the second pair becomes 2 times x plus 2. And you'll notice that, just like I was expecting, the parentheses, the contents of the parentheses are exactly the same. So my final factorization becomes x plus 2 times 3x plus 2. All right. So now if I'm solving 3x squared plus 8x plus 4 equals 0, I'm basically solving x plus 2 times 3x plus 2 equals 0. All right, which means either the first thing, x plus 2 equals 0, or the second thing, 3x plus 2 equals 0. And if I solve those separately, then I get x equals -2 or x equals -2/3. All right, so those would be the two solutions to that quadratic equation. All right, and here's another example of that. If I wanted to solve 2x squared minus 3x minus 9 equals 0, again, I would have to factor the left-hand side. So I'm looking for two numbers that multiply to give the first number times the last number, which is 2 times negative 9. That's negative 18. And those same two numbers would have to add to give negative 3, which is the middle number. Those two numbers are negative 6 and positive 3. Okay? So the second method I'm going to use to factor this is the box method, which we've talked about in a previous chapter. So I set up the box and I put 2x squared in the top left and negative 9 in the bottom right. And then I use the negative 6 and the 3 that I found to split that negative 3x into two parts. And those two parts become 3x and negative 6x. So then I look at each column and I factor out the biggest factor that I can. So from the first column, I can factor out 2x. And then from the second column, I can factor out a 3 out of both of those terms. Then I look at the rows. From the top row, I can factor out just an x. And from the bottom row, I can factor out a negative 3. All right, so that means that my two factors are 2x plus 3, looking across the top, and x minus 3 looking down the left-hand side. So that means instead of solving 2x squared minus 3x minus 9 equals 0, I can solve 2x plus 3 times x minus 3 equals 0. And if I do that, that means that either 2x plus 3 would have to equal 0 or x minus 3 would have to equal 0. So if I solve each of those separately, then I get from the first one, x equals negative 3 over 2, and from the second one, I get that x equals 3. So those would be my two solutions to the original equation that I was given. And that's how you solve quadratic equations by factoring. If you have any questions, please let me know, and I will see you tomorrow.